You with exciting discussion and panelists. So without further ado, I'm going to turn it over to Dr. Liz Reynolds, Special Assistant to the President for Manufacturing and R&D from the National Economic Council.
Thank you so much, Michelle. And great to see everybody again. Thanks to everyone who's here for this, to celebrate this exciting moment. As part of the NEC, we're delighted to partner with our friends at OSTP and at the NSC to launch this EO and to engage all of you in this exciting moment. This panel is about biomanufacturing, but of course, as all of us know in this world, the process is the product. So biomanufacturing has been part of this discussion right from the get-go. But I think that the importance of this panel is really about getting into what we've heard early on from White House leadership and from some of our other agency leaders, which is the how of building this industry, building bioeconomy capabilities in this country. And this panel is really about trying to drive home what does it mean to do this. And I'm really excited to have everyone here. I'll briefly introduce them, but again, I think you can find their bios on the website. But our goal here in the next hour or so is to talk about some of the topics that have already come up, but how do we actually take the R&D and move it into invent it here, not just invent it here, but make it here? What are the challenges that we have to actually doing that? And what are some of the policy ideas that people have that will help us advance this agenda? So let me just briefly introduce the panel. To my right, Dr. Christoph Schiller, the CEO of Geno, a biomaterials company. To my left, Dr. Tia Lyles-Williams, CEO of Lucas Pi Bio, which is a contract manufacturing company for biopharma. To my right, Dr. Doris Taylor, CEO of Organomet, which is a regeneration medical bio company. To her right, Barbara McQuiston, Deputy Chief Technology Officer for Science and Technology at the Department of Defense. To my left, Stephen Krosky, CEO of Danimer Scientific, a bioplastics company. And then finally, to my left, Dr. Doug Friedman, who is the Executive Director of Biomade, which you'll hear more about, which is a public-private initiative here in the country. So I'm going to start by having every one of the panelists give a few minutes introduction to themselves and to their company, so we have a sense of the breadth and depth of the biomanufacturing interests and capabilities here. And so I'm going to start, if I might, with Doug. I'm sorry, with Christoph.
Right. Well, first off, pleasure to be here. A wonderful moment in time for this industry and for this country. I think prioritizing biomanufacturing is a key strategic initiative. I'll give a little bit of background on myself. So I'm first generation born here in the U.S. The comments earlier on immigration, I can't support enough, coming from two parents who came to this country with a dream of providing an opportunity for their kids and what their kids could do. So I did my journey through Research Triangle Park at Duke University, went out to San Diego for my graduate studies, and had an idea to start a company about 20 plus years ago. And thanks to the National Science Foundation and an SBIR grant, I was able to actually do that. So Geno is an example over a long history of another one of these scenarios where government funding to support innovation and entrepreneurship really does make a difference. The company would not be here today if it wasn't for that. So we're very thankful of that. The company today stands at the forefront of delivering the technologies that will enable large-scale, large-volume manufacturing of widely used chemicals and ultimately materials that are derived from those, to be able to do that from renewable inputs instead of hydrocarbons. So we speak about topics like decarbonizing sectors of the chemical industry and so forth. We've actually commercialized 3 different products today. First product, and I'll give you an example of that, over about 4 million liters of installed capacity that's being put in place, over 100,000 tons of product that will be produced, and I'll give you a feel for where that goes in a moment and one of the examples around that. We talk a lot about being able to lead with technology and with manufacturing. Okay, so give you an example of what we've done. In first product that we commercialize is a molecule that most people haven't heard of, and so the molecule itself, to John's point earlier, getting closer to consumer products is what will make this sexy. But I will tell you, the molecule is called butanediol, BDO. Think spandex, think PBT plastics, think electronics, cars, these types of applications. A product that's made today 3 million tons in about 30 different petrochemical manufacturing plants throughout the world. Most of those plants recently that are being built to produce that are from coal in China. We've delivered a technology that can use renewable feedstocks with nearly a 90% reduction in global warming potential to be able to deliver that product. So 100,000 tons is what we're on the path to seeing produced with our technology, but in a 3 million ton per year market. So if we really want to be able to drive scale in terms of climate impact, that's the size of the opportunity that's out there. That's one product. We're also on the march to bring renewable feedstocks to make plant-based nylon with partners, brand owners like Lululemon. We're on the march now to provide alternatives to the supply chains that are dependent on palm oil with partners like Unilever to be able to drive those forward. So the possibilities for what we can do with biomanufacturing are substantial. The asks, I would say, are very similar to what you've heard in a number of cases, which in this case, I'm going to focus on the biomanufacturing level, which is really to provide support for the creation of large-scale commercial manufacturing infrastructure. There is a need for scale-up, absolutely, and you're going to probably hear that from others as well, but large-scale commercial manufacturing on the basis of the lowest cost feedstock in the world for renewable feedstocks, which is right here in the United States. So we're blessed with an innovation ecosystem that's amazing, but we need to be able to manufacture here in the United States. So opportunities to drive that, as well as opportunities to pull demand for these types of products. Most of the molecules that we'll make with biotechnology, many people won't know, but a lot of the products that they buy, and even a lot of products that the government buys, for example, they will know. I'll give you a simple example. If you just look around in the room, we have a number of flags. What are those flags made of? Probably made of nylon or a polyester that probably came from crude oil, that probably you won't even be able to know where that crude oil came from when you go and try to find out where it came from. So there's also an opportunity here for supply chain transparency, which is critical right now for a lot of brand owners. So I'll leave it at that, but thank you for the opportunity.
Thank you, Christoph. I hope our procurement folks are watching.
There you go.
Okay, Tia.
Yes. Good afternoon, everybody. Got you. Good afternoon, everybody. Dr. Tia Lyles-Williams, founder and CEO of Lucas Pop Bio. First, I want to thank you for allowing me to be here today and share what we're doing at Lucas Pop Bio. I want to thank my supporters that have came today, IMSCO Scientific, Berkeley Lights, Heliplex, Jefferson Institute for Bioprocessing, University City Science Center, and special guest 54 Gene of Philadelphia OIC. Lucas Pop Bio is a contract development organization, manufacturing organization. So what that means is that we manufacture drugs on contract, particularly biologic drugs. So if you had the opportunity to partake in the COVID-19 vaccine, those are the type of drugs we make: viral vectors, gene vectors, monoclonal antibodies, cell therapies, you name it, anything large molecule or biologics we're able to make. Right now, we're able to service our customer needs for preclinical studies. We work in partnership with Thomas Jefferson University at the Jefferson Institute for Bioprocessing, as well as a cell line developer based in San Francisco, Celtheon. We're able to produce material and develop manufacturing processes for those biological drugs, everything up until the point of sitting with FDA and getting permission to enter human clinical trials. Most recently, we just announced our CGMP facility that we're building out, 80,000 square foot bioprocessing facility in Southwest Philadelphia, PA. So this is an urban minority community of marginalized community members. It will be a full life science park. We're not only having Lucas Pop Bio, but the other anchor tenant would be Heliplex, which is an accelerator for life science startups to actually come in and manufacture their prototypes, so particularly seed-level companies. And then it will also double as a workforce development program that we'll get into later. And then the last piece of that campus is affordable housing. with mixed retail. So first-time homeowners, people that need that discounted leverage for the salaries that they bring in, and then also a section off for people participating in workforce development that may need some additional help while participating in that program. Just to give you a bit of background, my education, I'm an alum of Howard University, where I study biology. I have a master's in business from Full Sail University, a master's in regulatory science from University of Southern California, and just received an honorary doctorate from Thomas Jefferson University. I think I'm the face, or I am the face of what biotech is looking like now, what it's going to look like next as we move forward. But this is not anything new. It's just something that's been ignored. So as we talk about equity today, I just want to remind or offer a little bit of insight to say this really, medicinal procedures and surgical operations really begin in Africa, particularly Egypt. They were the first to discover things like cancer, syphilis, chlamydia, surgical operations to mend bones. And then as we move forward, African Americans and people of African descent continue to participate in this industry. You have Dr. Percy Levon Julian, who was the first African American man to own a biomanufacturing facility, but also developed a mass production process for cortisone and progesterone. So he is the real grandfather of the biopharmaceutical industry. You have Dr. Charles Drew, who invented the blood banking system and how we do blood transfusions that we still do today. You have the Tuskegee Airmen experiment, unfortunately and fortunately in some retrospect. And then last but not least, you have Henrietta Lacks, whose cervical cells are literally the foundation of this trillion-dollar industry that we built here in Western medicine. And so I just want to impart on you to remember, as we talk about manufacturing, to make sure we continue to talk about the equity piece, but also understand that the Industrial Revolution has always involved African Americans from down south, unfortunately with slavery with the cotton, all the way up to the Industrial Revolution back in the day when folks started migrating up to the Midwest to work in the steel mills and some of the other industrial companies at that time. And Lucas Pop Bio is at the forefront of that. Our C-suite is around 95% of people of African descent, 50% women. So we're really integrated in making sure that not only are we actively participating in this industry and doing the work to get the drugs that the patient needs, but also making it an equitable table for all members of America and around the globe to participate, not just as patients, but as employees, entrepreneurs, and all the way up to the C-suite. Thank you.
Thank you, Tia. Great. Doris.
I'm Doris Taylor, CEO of Organomat Bio. Organomat is bioengineering on-demand, personalized replacement hearts. Why? Because heart disease is the #1 killer globally. In this room, half the people in this room have heart disease. Look to the right, look to the left. If it's not the person to your right or left, it's you. Half the people in this room, and the number is increasing after COVID. 1/3 of the deaths in the US every year are from heart disease. And the only definitive treatment for heart disease at its end stage is a heart transplant. And yet, in the US, we only transplant 10 hearts a day when there are 3,200 people on the waiting list. And that means, and you take drugs every day for the rest of your life to prevent rejection. That means if you can't afford those drugs, if you are too old, if you are too sick, if you're not sick enough, you will never even make that list. My goal is to change that. We are building on-demand, personalized replacement hearts. We're biomanufacturing those in the US. We've proven we can do it, and now it's about scaling it up. So I think about biomanufacturing, and I want to emphasize the bio aspect of that, and the fact that we're talking about building therapies that are going to go into people's bodies and potentially promote a cure. For the first time, we can biomanufacture cures, but those are expensive. And that means we have to be able to scale up and build reagents and build tools and build hearts, build complex systems that are safe, reproducible, and that I'm willing to use in my mom or my daughter or my son, and therefore I'm willing to use in yours. As a result, we have a level of, we can't give a heart or cells or biologics to someone and take that back. We're putting those in to last for the lifetime of a patient, and so we have to build them to last for the lifetime of a patient. It's a new world for biomanufacturing. We've already seen examples of it. You heard EpiBone earlier today. And that means we have to have a new view of manufacturing. We're beginning to build that. Dean Kamen, Army, BioFab is building that in one instance, supported by the DoD. We have to change our paradigm. We have to be able to build complex systems, educate people how to work on those complex systems. Do you want somebody who doesn't quite know what they're doing building your heart? I don't think so. And we have to think about the fact that it's not a traditional business model. It's not a 5-year, $100 million, I'll give you your drug, I'll give you your heart. You don't want the heart I build that way. What I've said is you don't want the Rube Goldberg heart. You want the one that's going to beat every minute of every hour of every day for the rest of your life. And therefore, you want me to spend what it's going to take to get this done. I can't do it alone. It's going to take partnerships. And I heard so many things in this room today that are the necessary partnerships. And then the final thing I want to say is I grew up in a single-parent family in Mississippi. I didn't go to school on the East Coast or the West Coast. I went to school in Mississippi. We have to recognize that new ideas and new capabilities don't just exist on the East and West Coast. They come from throughout this country, from people who look different and act different and are different, and that's what makes us better.
Thank you so much, Doris. Steve.
Thank you, Liz. Good morning. I'd like to thank the White House for allowing me to represent Danimer Scientific and the bioplastics industry on today's panel. We've all seen the images of trash piling up on the beaches all over the world. This is a pet peeve of mine and why I'm here today. Our company is working to fix this issue. Danimer Scientific is a leading producer of PHA, a renewable and biodegradable plastic that can be used in a wide variety of applications. A few examples include drinking straws, snack food and candy packaging, and coatings for paper products that require moisture and grease barrier. We've got partnerships with many global companies, including PepsiCo, Mars, and Bacardi, and we're creating innovative solutions that brands can use to reduce their impact on the environment. Starbucks is using our home compostable, or straws made from our home compostable resin today in all their U.S. stores. So I was real happy to see Starbucks out there today. Thank you. Our material has been certified to quickly break down in marine, freshwater, and soil environments, as well as in home and industrial composts. While we certainly don't encourage littering, our material breaks down completely without leaving behind microplastics. And I will briefly explain, in hopefully in layman's terms, how this product's actually made. It's nature's way of recycling carbon. It exists. It's ubiquitous in nature. If a leaf falls from a tree, there's microorganisms in the soil that will consume the carbon in that leaf. They convert the carbon in the leaf into another form of carbon for their own metabolic uses. That carbon is PHA. So we replicate that process in fermentation. So I call it bug fat. We fatten these bugs up, and then we break that cell wall open. And by the way, the scientists will all discourage me after this because it's not fat, it's carbon. But we break that cell wall open, and we extract the PHA from inside the cell wall, and that's the beauty of it. That is the plastic resin. And so if it escapes or leaks into nature, it's a preferred food source for bacteria and will go away, even in a marine environment. Our company was founded in 2004 in Bainbridge, Georgia, a very rural community in the southwestern part of the state. And I'd like to give I guess Tia gave the first shout out actually, but I'll give a shout out to all the farmers and local business people in Decatur County who had a vision of a better future and funded this company for the first 15 years of our life. It's really cool to be here today, and hopefully you folks watching at home, you should be proud of where we're at now. Since 2004, we've invested hundreds of millions of dollars into PHA and created hundreds of STEM-related jobs. In 2018, we purchased and began retrofitting a shuttered fermentation facility in another rural community, Winchester, Kentucky. In 2020, we began shipping degradable plastics from this facility. We recently broke ground on a new manufacturing facility in Bainbridge that will increase our capacity to approximately 190 million pounds of plastic resin and create an additional hundreds of well-paying jobs. In 2021, last year, we also acquired a company in Rochester, New York called Novomer, a startup that has developed a complementary PHA that will help us increase capacity and target new markets. We're proving that bio-based manufacturing can not only create sustainable products to help the public and private sector achieve our ESG goals, but also help improve livelihoods in rural communities. You can really see the positive impact our company's success has had when you go to the little square in Bainbridge and see the bustle and hustle of activity there and all the new businesses that's starting up, things that weren't there 10 years ago. I find it very exciting. The National Biotechnology and Biomanufacturing Initiative, just announced by the White House, provides the vision and essential framework for growing the U.S. bioeconomy, and I applaud President Biden for his leadership. Thank you.
Thank you, Steve. Doug.
Thanks, Liz. I am so pleased to be here today with you all. This day has been a long time coming, and I want to first thank President Biden, his leadership, as well as the leadership of countless individuals, many of whom are in this room, many of whom are not in this room, many of whom have been working on this for a decade or more to really get to this point, which I truly believe is a pivot point. We are at an inflection point in biotechnology and biomanufacturing. And I am also pleased to be going at the end of the day after we have heard from so many companies, so many federal agencies really talking about the whole of government, whole of country approach to attacking this problem and really making a substantive difference. I am also pleased to represent BioMade, a Manufacturing USA institute focused on bioindustrial products. We were catalyzed by the Department of Defense almost exactly 2 years ago. Our 2-year birthday is in 6 days, which is really hard to believe. And we are now working with companies, universities, nonprofits, community colleges in almost 30 states. So to the point about how biotechnology and biomanufacturing is really a whole of country approach, if we do not have all 50 states, plus the District of Columbia, plus Puerto Rico, plus other parts of the country, all in it together, we will not reach the full potential, the $30 trillion potential that was discussed earlier today. I'm also pleased to announce that today we have our next crop of projects kicking off. So we have almost $20 million of effort across 9 projects, that include some of the companies and universities that have been represented over the course of the day. It's noteworthy to me that of the panelists that have participated in this summit, more than half of them are involved in Biomade today. And my message to the half that aren't, and to all of those that are out there, we really hope that Biomade can serve as a bridge to help bring the governmental sector and the private sector closer together, translate for you, so that the economic promise that we've been talking about today comes out. I want to thank Representative Ross for bringing up community colleges very early in the day. Biomade focuses on technology and innovation, but we have a very strong workforce development push led by Dr. Tom Tuban, our head of workforce development, who really is a master of working with the community college infrastructure in this country. If you look at how biology and biotechnology has evolved over time, it has largely involved four-year universities. And that's not necessarily surprising as you watch a technology go from early stage to getting closer and closer to commercialization. But as we really start to think about what does manufacturing look like, if we are at the scale and having the impact that we're talking about, the community college infrastructure in this country is a national treasure. And we should be leaning heavily into that and leveraging it and building on it to represent the diversity that we can. The final two comments I want to make are also about standards, norms, safety, security, and transparency. We have a thrust that we call 4S, safety, security, sustainability, and social responsibility, that permeates everything that we do. And I've been exceptionally happy that the companies that we work with are really the driving force behind this. Companies that have started in this industry really take very seriously all four of those pillars and want to work together, want to work with the academic sector, with government, with civil society writ large, to make sure that that maintains and sustains as the industry grows. And the last thing I'll comment on as we get into the discussion here today is that biotechnology over the last 20-ish, 30-ish years has been sustained by billions of dollars of U.S. federal investment. Every single federal agency has played a role in one way or another over that time. And now we are at a point where we have to take all of that underlying innovation that we have and that we have developed and that we have supported and translate that into commercial enterprises, companies that have a wide diversity of business models, some that are focused on products, some that are focused on platforms, some that are focused on underlying technologies, some that are focused on sensor systems. I could go for a long time, but I will stop here. Bring them all together and build to commercial, profitable enterprises that ultimately deliver the solutions that are contemplated in the initiative that we're discussing today. And that's what I hope Biomade, with the federal government, with the rest of the ecosystem that's been developed and will continue to develop, can do simply as fast as possible.
Thank you, Doug. And last but not least, Barbara.
Thank you. I'm really happy to be here. You know, my career has been at DARPA and now over at the DoD under the Secretary of Defense and the Science and Technology portion. And, you know, when we at DARPA, we're dreaming about, you know, what could be possible and looking at where the technology could go, how it would impact our, you know, our mission's performance, the future global challenges that we have here. And many of you here are a result of a lot of the investment that was made in the early stages of being able to dream and make that happen, where we have Amyris, Biomason, Ginkgo. I mean, I could go on and on with a lot of people in this room right now who probably could point back to some of their roots of where they were. SBIR program, that's awesome, and DARPA, but these investments are extremely important. One of the good things about DARPA is they can prove where you can push the frontier. but there's a whole other portion of investment that has to go forward in order to have manufacturable support of the product in the industrial base. And the Defense Department cares a lot about that. We care a lot about that because we buy materials, we buy lubricants, we buy sustainable fuels, we buy resins, precursors. There's so many things, rubber, that we're dependent on for our supply chain, that we really pay attention to how the industrial base is working and what can we do to move forward so that we have national and economic security that we can have for this country and our domestic manufacturing. As Secretary Hicks mentioned, we have $1.5 billion in biomanufacturing going forward, and a lot of that is in our manufacturing innovation institutes, both of which are represented here. You just heard from BioMade, and there's BioFab and Army out there, which is Dean is in the back there, so Dean Kamen. And these sort of investments are where we can have public-private money coming together, where the Defense Department can put their manufacturing challenges forward so that we can create an ecosystem around key areas of biomanufacturing to de-risk the manufacturing and help accelerate both the scaling up and the scaling out of this technology, because it really is something that's going to change the whole paradigm of how we look at many of the things we do across the board. So it's hard to even list all the things that this touches for the Defense Department and for all of us in this nation. But having the ability to produce that ecosystem, to have the companies and the universities and the large companies that have needs across the board come together and work on doing this together, on getting these hard challenges and addressing them, is key. When I think a lot about one of the things that's the key basis of why we're here right now is because this has become taking biology and putting it into a predictable engineering practice. And that's the basis of what we're looking at, but what we can manufacture is also key. When we look at being able to synthetically make rare earth metals and other things, that's a catalyst for so many of the other industries that we need to move forward in clean energy, electrification, other things. So this is a huge portion of security for this nation. And so how we step out on that is going to be key, but we have to catalyze it. We have to bring together the public-private partnerships. We also have to care about where we're getting the workforce and where the future is, and in a lot of the STEM education that goes on. We have a lot of efforts in this. We work, an example is the FIRST Robotics program that Dean Kamen has, where you're looking at being able to touch tens of thousands of students and giving them challenge in competing in robotics, 3D printing of biomaterials, learning basics of how tissue and organ manufacture can move forward. What you really want to do is be able to have the STEM education in place so that the students from the next generation can see themselves in this industry and moving forward. We can have the next Doris Taylor out there who has a dream of where they want to be and can see themselves in that dream. And this is going to be incredibly important. We also need to tap into what we have, which we're looking at relative to certification and training programs. Where are we going to get the workforce from? And how are we going to transform the biomanufacturing technicians that we need today, working with community colleges, universities, developing all of the materials that are needed to move that forward. So all these things come together as well as the individual investments that we have with specific universities, Arizona State, Boston University, UC Santa Barbara, that are developing K through 12 student teacher training courses with the community colleges and university activities all around biotechnology. We have a center of excellence in biotechnology at North Carolina Agriculture and Technical State University. All of this is helping move together education, workforce development, and the industrial base that we have. And this is really exciting because in the end, everybody will be looking at it saying, well, of course everything's biologically manufactured. I'm from DARPA. I understand this. When we started off with automated car driving, it was like, people thought we were nuts. Now everybody's like, well, why doesn't my car park itself? So someday you'll be in this room like I am now, and everybody else will be saying, of course, everything's biologically made. Of course, we're using CO2 and all of the things that are a problem right now into an opportunity. We have that chance to transform the nation and to transform how globally we approach these challenges. And I'm very excited to be here, and I'm honored to be here in a room of such great people that are actually helping us move this forward. So thank you.
Thank you, Barbara. We're going to shift now to one of the topics that's been, I think, present throughout the day, and that is the issue of capital and scale-up. This has been a challenge not only in this industry, but across the board for the U.S. We have an incredible startup ecosystem. Our scale-up ecosystem leaves a little bit to be desired. We have companies here on this panel that range from 2 years old to 20 years old, and I think they all have really worthwhile experiences to share with us about their capital challenges and opportunities and the scale-up challenge that they see. So I'd like to start with that conversation. I will ask the panelists to be a little bit tighter with our responses. I love hearing from this panel, and we have a lot to say, but let's try and keep things to a couple minutes. So I'm going to start with Christoph. Christoph, you've talked about being, starting 22 years ago, and the challenges of commercial production in particular, which we know other countries are much more aggressive about supporting companies and others in their commercial production. Can you talk a little bit about your pathway?
Yeah, let me share I think the story of BDO in a little bit more detail to give you a feel for that. We today face this scale-up challenge in terms of the U.S. and where the opportunity sits, and in that I think we have 5 scale-up programs that are underway today. They're all being scaled up in Europe. We have originally, when the first commercial facility for BDO was built, it's in northern Italy, 30,000 tons. It was about a $150 million capital investment to go build that facility. And fortunately, though, there's a great example today on BDO where that's being scaled up in the U.S. So there's a 65,000 ton per year facility that's being built by an entity called CORE, Q-O-R-E. It's a joint venture between Cargill and Helm, which is the largest bulk distributor of chemicals globally. And it's in Eddyville, Iowa. And why is it in Eddyville, Iowa? Because I'll highlight a couple things that are really important when we think about commercial scale and at the volumes that we're talking about, which, to be honest, are still small relative to what you're competing against, okay? So you really need to think about low-cost feedstock. You need to think about infrastructure. And you need to think about renewable energy. And why renewable energy? Because the existing petrochemical industry, what they will do is they will switch to renewable energy and claim a lot of positives from that. And that's a good shift. We need to see that. But that also means that if making bio-based products, if we're not using renewable energy, we're exposed, right? So you're exposed to that. So I was great because wind power, huge investments were made into wind power. Why Eddyville, Iowa? Cargill has a very large biorefinery that sits in Eddyville, Iowa, that provides low-cost feedstocks, right? And ultimately, this plant will provide value-added outlets for farmers in Iowa. It'll create probably 50 skilled jobs to operate that type of a facility. So it's a great example, but it gives you a feel of the scope of that, and that's a $300 million capital project, right? And again, that's just a start in a very large market opportunity. So that scale-up challenge, we're seeing a good example here in the U.S., but over in Europe, we see a lot more demand pull for products, a lot more recognition around climate and carbon and how to account for that and how to address those issues. So it's this opportunity, right? Lowest cost feedstock in the world here in the U.S., the innovations here in the U.S., if we can get the ecosystem right, which we're making good progress, I think, here with what's happening today, there's just a tremendous opportunity. But there has been a history where we've had to go elsewhere for a lot of this, and we lived that firsthand.
Thank you, Christoph. And I think to your point about demand pull, hopefully we see a lot of activity by this administration, particularly around the Inflation Reduction Act and climate-related things that are going to help with that. When you talk about the ecosystem, I want to turn to Doug, whose institute, one of the 16 Manufacturing USA institutes. If people are not familiar with these were set up a decade or sooner, and are focused on trying to move from lab to market, because that we have understood that that's a weakness here. And so 16 across different types of technologies, including, I want to mention Kelvin Lee, Executive Director of Nimble, which focuses on biopharmaceutical innovation as well. Can you talk a little bit about your being a bridge on this scale-up point, and just briefly explain kind of how that works?
Sure. I'll tell a very brief story that I think clearly articulates what is going on here. When Biomade was negative 18 months old, so about a year and a half before Biomade existed, the Engineering Biology Research Consortium pulled together as many companies as would show up in a room to talk about what does the industry need to be successful as an industry, right? To do exactly what we're talking about. And it was a listening session. The number one thing that came up, literally every company who showed up in one way or another brought up scale-up infrastructure. Now, it turned out at the time that was like the only thing off the table. So we're really grateful to the DoD for stepping up in a serious way right now to throw that on the table. But that's what we heard. And we heard story after story about how companies were getting to the point where they've developed a set of underlying technology. They have products that they sort of know how to make. We can get into that if we have time. But they need to scale them to the point where they're making a relevant amount of material so customers can test them. And virtually all of them were going outside of the US. And so this idea of how do we think about scale-up infrastructure in a networked and cohesive manner that's able to capture the most relevant parts of the chemicals market. And so the other aspect of this to bring up that I really appreciate Christoph commenting on the scale that Gino is talking about is still small compared to the industrial chemicals market. I urge you to just think of the petroleum industry, the whole thing. That's what we're talking about, right? That is what we are talking about. That is the scale of carbon that we are talking about. And in order for that to have a meaningful impact, in order for all of these technologies to have a meaningful impact, as quickly as possible, companies need to spin out a kilogram, a few kilograms, a ton of product so that customers, like the DoD, for example, can go test that, right? How does that work in a system that is relevant, right? How do we get that in the hands of customers quickly? How do companies fail in product development quickly, right? Would you have to wait a long time and go overseas? That's a lot of money, right? You're burning money. A product fails, now all of a sudden you don't have any money, your company goes out of business, right? That is a pretty bad place for the industry to be if companies are going out of business when their first or second product fails. You've got to be able to iterate quickly. And so the idea of how scale up manufacturing and what role CDMOs in the bioindustrial space work is a real opportunity now. And I think this initiative provides a really strong foundation that now many federal agencies, and I really hope Congress, take some ownership over and say, if we're going to do it, we have to do it right now because we are already behind, but we have an opportunity to catch up, and we have an opportunity to catch up in a way that the companies build their manufacturing capacity here.
I'll add one more comment to that, and that is that we care a lot about what the demand signal is too, because for the DoD, if we need to have it in the industrial base. If you can't make it, we can't buy it, and it doesn't help us. So we're launching the Tri-Service Biotechnology for Resilient Supply Chain with $270 million over the next 5 years in order to be able to bring that bio-based materials, fuels, fire-resistant materials, polymers, resins, we can go on and on as to what we have and what our need is, but to start to bring that into the supply chain, because that demand signal will be huge as far as being able to qualify it, get it into the system, and have it there for the DoD and move it forward. So I think that's one of the things that we're doing right now that will be helpful.
Say one thing, Doris, yeah.
we have to do this for biology too. We have to think about the bioproducts.
Great. Okay, speaking of, thank you for that, the bioproducts and also CMOs, et cetera. Tia, you want to talk a little bit about your finance pathway?
So just in response to that, for a CDMO, it takes a great deal of investment. So for instance, we're a startup. Our startup costs $130 million. Now, while this is significantly cheaper, right, than some of the larger CDMOs that are building facilities for 800, 900 million, it still is a struggle, right? Traditionally, CDMOs in the U.S. have started out as biotech companies with products that may have failed or they may have not wanted to move forward for whatever reason, so they transform into CDMOs in order to provide a return on investment for their investors. Unlike us, with Lucas Pot Bio, we're starting out as a CDMO on purpose, right? Our primary goal is really to service the needs of life science startups that need to build these prototypes so they can get in front of FDA and push it through human clinical trials and then get it out in front of whatever regulatory agency for the commercial market. So it's two things with CDMOs that comes with growth and scale. One is obviously the startup investment to build this monstrous facility that we need to build to manufacture all these different type of molecules. But the other part is the investment into the startups and the small and mid-sized biotech companies so they can afford the services that we offer. And then the last but not least, even with government contracts, the other part to make this thing work as far as the bioeconomy is requiring that some of these larger players that get these contracts so often, whether it come from BARDA, DARPA, DOD, we've actually responded to a request for information concerning how we would be able to participate and be beneficial to Biden's order of bringing manufacturing back to the U.S. and more importantly, helping to manufacture some of these vaccines for COVID-19 and what else is coming our way, right? Is that COVID-19 is definitely not the first and it's obviously not the last as we have the onset of other things coming along, including the monkeypox. So with the bit of the government contracts, what we offered in our proposal to the response to BARDA was that a requirement needs to be there, similar to how you have in the construction business, right? You have construction companies, architect companies that subcontract to minority companies. It needs to be done the same way in the CDMO industry in order to build up this bioeconomy that's going to be equitable in all types of communities and not just the same suburbs that has always been traditionally. And then last but not least, making sure that DEI and that equity is built in not just in subcontracting, but also the way the larger company looks. So we can't have the same faces at the C-suite. That needs to be diverse. When you build in this equitable piece and this diversity piece, it really does circulate that dollar, right? That's how it used to be in the past. That's how you have, cities that used to thrive, like Gary, Indiana, where I'm from, Chester, PA, all those Rust Belt towns. They thrive because they had a diverse community with a diverse economy where a dollar constantly circulated before those particular industries were taken away. So again, to summarize, it's two things for the growth and scale and what we're asking for the U.S. to do. Inject that money into the life science startups, including myself as a CDMO. And then also the other part is there need to be some type of financial support to build these facilities in order to improve the workforce and improve the local bioeconomy within these communities.
Thank you. Doris, did you want to have one word on financing?
Financing companies in this space is not a five-year traditional business model. And we're going to have to think about it differently. We're going to have to acknowledge that building biology is not the same as building small molecules. I love molecules. I love all of the things we're talking about. Molecules are not cells, they're not tissues, they're not organs. And the level of complexity and the pathway forward is different, expensive, and we have to start government. I believe government has an opportunity here to actually enable companies to move beyond simply the idea and get us to some successful products.
Thank you. Great. Let's shift now to the other, I think, another key topic that we've heard all day about, which is workforce and developing the workforce for this industry going forward. Certainly, we have a labor shortage, as we know, across the country now, and we certainly had a labor shortage, particularly in manufacturing, before the pandemic, and trajectory-wise, that will continue, and given demographics, et cetera. So how are we going to bring in the next generation of workers? And I think the opportunity here, as we've heard, ranges from our high school and community college kids all the way up through PhDs. So let me first turn to Steve and what you've been doing, as you said earlier, in Georgia and in Kentucky, to recruit and to train workers in your business.
Sure, Liz. First, I have to say I looked to my left and to my right, and I realized Doug was obviously a member of Biomed, so that means I'm not. But we'll fix that. Okay. Hopefully, my heart's okay. Okay. So we have fantastic employees, but we operate in a very rural community, in very rural communities. So you can imagine if you need to hire somebody with a master's in chemical engineering or a PhD in microbiology, that's tough to find. One of the things that we've done to help mitigate this is having a fairly robust internship program where we identify kids at the high school level and start bringing them in the summers, and then we help sponsor them when they go to college. And we have had several kids like this who started with us in high school and went on to get PhDs and have now come back and worked for us. And I think this is something that the government could help us with by subsidizing internship programs, developing scholarships for STEM scholarships, but tied to the student coming back into that rural community to get their first job. And so I think those are some fairly simple things that could be done to help.
That's just great stories, Steve. Really inspiring. Tia, did you want to say about from rural to urban?
Sure. I think, we talk about K through 12 and college and the PhDs and things alike, but the target market that's really missing is the workforce, the ages between 25 and 45. So for Lucas Pop Bio, we're partnering with several organizations, some that I mentioned here today, EMSCO, Jefferson Institute for Bioprocessing, UC Science Center, and building a workforce development program that targets the market from not only entry level, but all the way up to C-suite and pops out to entrepreneurship. The entry level program is a 36-week program, paid. They come in, they learn to become a bioprocess operator and a quality control technician. They even have an opportunity to gain 6 college credits, whether it's graduate or undergraduate, particularly from Jefferson Institute for Bioprocessing. And the reason why we're targeting that market is because they're already experienced, right? They've already been in the workforce. They know the nuances of communications and the expectations of what to do when it's on the job. And more importantly, after that, it provides the next generation from K through 12 to see somebody that looks like them actually doing the work, being able to come in, whether they have a degree or not. Ours is a minimum of a GED or a high school diploma. However, we do welcome people that may have degrees. But the point is they need to actually see people actually doing the work to get them interested to, what was the word today, to make it sexy, right? To get them interested in doing this type of work. And more importantly, again, building that bio economy. As far as the members of marginalized communities that may already been working in biotech, I'm the face of that. I've been working in the industry for 22 years. I've worked at Baxter, I've worked at GSK, I've worked at Amgen, Lonza, you name it, I've been there. All these companies that I've named, I've never once got hired directly. I've always had to go through a hiring agency or a temp agency. So that means I often went 6 months to a year with no benefits, no PTO, every time I had to move and start over. With our program, we're requiring that these graduates from our program to be hired permanently as employees. There is a 120-day probationary period for the company to say, okay. Once the company says, okay, they pay 12% of that salary back into this program so that it remains free. We'll be piloting this program next summer in the city of Philadelphia. We already have employers attached to it. Lucas Pop Bio, obviously, we need around 250 people when doors open in 2024, so we'll be doing ongoing hiring. We also have Delaware State University as a participating employer with their molecular lab that they have have down in Wilmington. And then one of the biggest employers that we have committed to date is Spark Therapeutics. And I think the reason why we're able to attract somebody like Spark Therapeutics is because it's not just the academia portion of the curriculum with Jefferson Institute for Bioprocessing or UC Science Center's BULB program, but it also includes the industry trade organizations such as ISPE, ASQ, and RAP. So now it's not just Tia and her company, her partners saying that these individuals are qualified to do the work. Now we have third-party certificates of completion and certifications to advocate for them to say, hey, these folks are ready to work. But that is really the target market we need to concentrate on if we're going to level the playing field and close this wealth gap in marginalized communities.
Thank you, Tia. That is really inspiring and speaks to the whole ecosystem and how we build partnerships. And I just want to do a shout out for 4 of the winners. Senator Warner talked about the Build Back Better Regional Challenge, and just a few weeks ago, EDA announced the winners. This is a really impressive investment in a type of area where communities have competitive advantage and can build out community work. And we have a number of the winners here from Virginia, Oklahoma, North Carolina, and New Hampshire. And this is exactly the kinds of programs and ways in which we are trying to build out not just the technology, not just the R&D and the scale up, but the workforce and the impacts on place. So very excited about that. We are, needless to say, running out of time. So I'm going to wrap us up at this point with an exercise that I think should be interesting and engaging, which is to ask each of our panelists to, in a minute or so, let me just say in a minute or so, to talk about what policy or policies you'd like to put forward and have this broader community consider and be part of our initiative here around building the bioeconomy. So I think I will start with Christoph.
All right, well, I already mentioned a couple. So
Yes.
I think infrastructure in terms of funding at the commercial scale, there's vehicles that exist, I think, to help fuel that. They need to be charged up, I think, with more dollars and widened in terms of the scope of product opportunities they support. These are topics like, or programs like loan guarantees, for example, those types of issues. On the demand side, I think strengthening the BioPreferred program and thinking through on the BioPreferred program the kinds of products may not be necessarily biomanufactured, but it may be downstream where you start to see the biomanufactured ingredients coming into products. How do we capture that in a BioPreferred to pull demand? And then the third is a little bit more aspirational, but if I think about the climate crisis that we have and how to address that, figuring out ways in which we put a value around carbon and the carbon savings that biotechnology and biomanufacturing can deliver is crucial. How to think about putting a value on that and how to think even about concepts like carbon border adjustment mechanisms to create a level playing field internationally. Those would be my top items.
Great, thinking big. I like it. Doris?
I have really 3 things. I have 3 things. The first is I think from a policy perspective, anyone who gets federally funded research that is commercialized and results in a product, if those individuals were asked to pay a small royalty back to a fund that actually would be used to support new codes and new ideas, we could feed forward. It could be a give back. I think number 2, if the government created online tools to educate both process and engineering people about biology people about process, we could shorten the path to products and decrease risk. I think if we also created a business mindset so that science is created in a clinically relevant or business relevant way in academic settings, and that were rewarded at the level of government funding, that would change everything. And then finally, I think creating a common vocabulary and a dictionary of biomanufacturing, bioscience, biotechnology, and making that available so that we're all speaking the same language.
I like that. That would be a step forward. Tia? Oh, sorry.
That's all good. That's all good. We're sharing. First thing is, as we talked about funding before, for scaling and growing companies, but also, again, minority-owned companies that obviously don't have the same access to funding. I think there needs to be funding to support those companies and making sure that larger or majority Caucasian companies have an equity piece when it comes to supply chain. So making sure minority-owned lab supply companies, CDMOs, CROs, take your pick, have a seat at the table and have a real opportunity and a shot to go after some of these government contracts. The next thing is advocacy and voting for a bill that we've been working on with Representative Butterfield out in North Carolina. It's called the American Biotechnology Workforce Development Centers of Excellence. It's a bill that's proposing a minimum of $1 million to support not only community colleges and universities, but also apprenticeship programs like the one we're building with my partners to really build a pipeline to the workforce and make it more equitable. And then last but not least, similar to I think what Doris or either Barbara just mentioned, I forget who just said it, but some type of funding for life science startups, particularly minority-owned, that need the funding at the seed level to really build their prototype to get in front and gather the data they need to get in front of the regulatory agency to move towards that next step of human clinical trials or human factors for the medical device people. All of those things will help build the bioeconomy and, more importantly, make it more equitable for everybody to have opportunity.
Thank you. Steve?
Thank you, Liz. So on the last panel, John answered this question by saying he wanted $1 billion. So we'll take $2 billion, and that'll settle for $500 million. Okay. So most of the plastics industry is focused on improving recycling rates, but recycling is not a complete solution, and you can imagine who's behind that narrative. There are many applications where plastic cannot be recycled, and less than 10% of plastics are being recycled today. So it's minuscule. I believe that home and industrial compostable plastics are a key part of solving the plastic waste crisis, as these products can be disposed of with food waste, which is something that we're going to have for a long time, is food waste. A growing number of states and localities are passing bans that don't consider this industry-led innovation. Federal policy could help create an environment where biodegradable plastics can be widely adopted. Secondly, there's a current tax policy that gives $1 per gallon to blenders of biodiesel. So if you're using vegetable oil in your diesel fuel, you're getting $1 a gallon tax credit, which disadvantages the rest of us that are buying vegetable oil and trying to, do things that are environmentally friendly. So there's a current legislation being considered that's bipartisan, H.R. 2532, the Renewable Chemicals Act, which would go a long ways towards solving that discrepancy. Finally, and I hope Barbara's listening down there, when we talk about scale, we're not just talking about building factories, but we're talking about selling the factories out and selling that product, because obviously the more product you sell, the more overheads you can carry, per pound. You can lower your cost, which will accelerate adoption. And the U.S. government is one of the biggest purchasers of plastics, and the U.S. military are one of the biggest users of plastics in the world. And so that's something, I would like to just point out that, the U.S. government could encourage use of these products internally. And this is not hypothetical. These products are available today, and you can buy them right now. Thank you.
Thank you. I think message heard. Doug?
All right, Liz challenged me to 1 minute, so I set a timer. I'm going to bring up 3 things. So first, tying procurement into the mix. So one of the problems that we have is you scale a product, but then you're uncertain about a customer. Lots of government customers are available, lots of government R&D goes into it, but then if the government doesn't buy the product at the end, there's a problem. Gotta tie procurement into it in a robust and meaningful way. Climate resiliency. Biology and biomanufacturing has an opportunity to be truly distributed. Right now, the chemicals industry in the industrials market is highly localized in a bunch of places that are just getting hammered by climate change. We can use that to expand, to hit all 50 states so that when climate change is hammering one part of the country, another part of the country is online. We still have to solve the climate change problem. Last, infrastructure, tying in infrastructure to really meet company commercial needs so that the industrial base is there to serve. I was 8 seconds over, I'm sorry.
Good job.
All right, Barbara, less than 1 minute.
All right, I have a lesson one minute. Need to be pioneered, and government needs to take a strong hand in that to make those tools available and to work that. Public-private investment and working cooperatively with the industry, but also looking at how we can accelerate regulatory processes under the new paradigm of how we're doing things. And finally, to expand the opportunities and the mentorships, especially in the underrepresented populations, because we need to have everybody on board this industrial revolution. So thank you.
Wonderful. Well, thank you all. This has been a fantastic panel and clearly an exciting agenda ahead. I'm going to hand back to Michelle now.
Thank you all. As Liz mentioned, what a great panel. Thank you all to all of our speakers. Let's do another round of applause for the panel. And finally, to close, I'm going to turn to Dr. Megan Frisk, Director for Biotechnology Risk and Biological Weapons Nonproliferation, to end our day today. Megan, over to you.